Hello, welcome to Angular After Dark. I'm Lars Brink. I'm the author of this live stream, Angular After Dark, and I'm also the author of recently released book, Accelerating Angular Development with Ide. I'm also not the only sole author, I'm the co-author, as you might see here. So it's me, Lars Brink. It's Gyrup Brink Nielsen, also a Dane, and we have Santosh Yadav from India, who wrote the foreword. Hi, Oscar. Welcome to the stream. I'm just celebrating the book release, and I want to read chapter 2 because that's a chapter that's available to read for free, and it's a pretty exciting one, depending on what you like to learn. Yeah, it's available for free. So let me show you how you can read it yourself. But I'm basically going to try to read the whole thing. It's about 20 pages and pretty technical. So I'm going to read it all and let's see how it goes. Please let me know if the font is too small for the book. We'll figure something out. I have a few solutions in case it doesn't work out with the first try. So, first of all, there's a public GitHub repo for the book. It's on the Pack Publishing organization. It's called Accelerating Angular with Development with Ide. And inside of this one, you'll find down here, there's a link into all the projects for all the different feature apps. And here in part 2, you will be working with the Angular Academy real-world application. There's 4 chapters where you're just hands-on with coding, using all the skills you learned in the first part, and a few ones for the third part as well, which focuses on tooling and the compiler and a few other things. Anyways, of course, there's links to somewhere to the actual book. One of them is at the top here. If you click the image here, you'll go to the Pack Publishing product page. This is where chapter 2 is actually available, the full chapter, so you can read it immediately on this address. It will be down here, right? So here's everything if you want to read it for yourself. But I'm going to grab a PDF copy here, and I'm going to start with the first pages just to see what's in there, and then we'll continue to chapter 2. So the title, Accelerating Angular Development with Ide. Subtitle, A Practical Guide to Building Faster and More Testable Angular Apps with the new Ide engine. And just some information about Pack Publishing and the people involved there. And here, we might already need to zoom. I can kind of see here. So let me zoom in a bit. So this is the dedication of the authors, Jacob and myself. So mine reads, this book is dedicated to my daughters. I have 2 twin daughters. They're 10 years old. Because they inspire me to always do better. And also my greatest thanks to my wife for supporting me and all my extracurricular activities, such as writing this book and such as doing this live stream after dark. And Jacob's dedication is, he dedicates the book to the Angular community. All right, let's try to scroll here. I'm not good at this. So here's the foreword by Santosh. Angular Ide was first introduced in Angular version 9 in 2020, and it has been kind of a black box for many developers. Few developers know much about Ide, but Lars Brink is one of the leading Ide experts in the world. Thank you, Santosh. This is the first book that goes into more detail about Ide features and tooling. It is a must-read for all developers at all levels. Even if you're an expert in Angular, you will learn a lot from this book. This is the foreword by Santosh Yadav, who's a Google developer expert in Angular. He's a GitHub star, Auth0 ambassador and a co-founder of This is Angular and This is Learning together with me, and he's a freelance software consultant as well. So yeah, that's right. That about sums it up. You'll learn. I mean, this is not for an Angular beginner. You need to know what a component and a service and dependency injection is, and setting up a project, things like that. But other than that, this book is for you. If you've used Angular for a few years, or if you're an absolute expert, I guarantee you you'll learn something. This is assuming that you know Angular, all these things we just talked about. It's assuming that you have been using Angular up until version 8, maybe newer than that, but you haven't paid much attention to the new tooling, the new features and APIs and major changes in the Ide engine and Ide generation of Angular. So the book covers versions 9 to 12, and it tries to highlight the features that I find most interesting, while at the same time not covered very well or at all by documentation, articles, videos, books until now. So plenty to learn here. Yeah. And there's some more information about me and about Jacob and Drayson, and a few more dedications here. Mine reads, I want to extend my thanks to my computer science professor, Hans Hüttel, for being an inspiration early in my career and for teaching me regular expressions. And Jacobs reads, I want to thank my wife, Anita, and my daughter, Sophie, for understanding why I spent all those hours in front of a computer screen. And yeah, I know that feeling. And here's the reviewer, Anu, who reviewed one of the early final drafts of the book in its full length. So thank you for your feedback, Anu. And his dedication is, I'd like to thank my wife, Hima, for always giving me the freedom to pursue my interests. So lots of wives and family supporting authors like us. Okay, Oscar, you have a question here. There's a good section that talks about AOT on Ivy with AOT as default. Okay, so you have the book, I guess, and this is the table of contents. So that must be in part 3, which are the final 4 chapters. So let's try to locate that here, I guess. Oh, here it is. Yeah. Chapter 12, Embracing Ahead of Time Compilation. I can't show you the content here. I can only show you chapter 2. You'll have to buy the book for the rest or go into the examples in the repo. But yeah, let's have a look at the content of that. Technical requirements, using the Aot compiler for all development phases. For example, ahead of time compilation for builds, component templates, unit tests, and the runtime. Then there's a section on dealing with the Aot compiler's limitations. For example, providing values using functions, declaring metadata using functions, using tag template literals in component templates, initializing metadata variables. And then the final section is initializing asynchronous dependencies. So providing an async dependency with a static platform provider, or resolving an asynchronous dependency with an application initializer. So yeah, and Oscar recommends this 12th chapter. I'm glad you liked it. So yeah, so this is the book, and its 3 part is first part is chapters 1 to 4, and that's all about new features in TypeScript and Angular components, and in tooling and configuration. Comes with Angular, and a bit of testing, and CSS custom properties, and the new provider scopes that are called the platform and the any provider scopes. And these two in particular are some new major features that haven't gotten a lot of attention. They're kind of just there almost accidentally. So this chapter here goes into details. Like it's, let's see, how much is that? My math doesn't work. My calculator doesn't work right now. How many pages is this? Is it 18 pages? Yeah, something like that, about these two topics. And then the chapters 5 to 8 use these features to add additional features to this real-world application called Angular Academy. Jacob and Andresen wrote the second part, the hands-on part, and I wrote parts 1 and 3. And but let's have a look at chapter 2 here, the outline, the table of contents. It's called Boosting Developer Productivity Through Tooling, Configuration, and Convenience. So there's some technical requirements. We're going to look at those. Then there's using predictable style bindings, outputting faster and smaller bundles with Aot compilation, taking advantage of strict mode and other new configurations, enhancing our Angular testing experience, leveling up our developer experience, and then some sub topics. So those are the 20 pages I'm going to read for you now. And now it becomes important that we find the right font size here. Okay, let me try this one. 200% zoom. I don't know. 225 or 225. Okay. There we go. Boosting developer productivity through tooling, configuration, and convenience. That's chapter 2 of Accelerating Angular Development with Ivy. And yeah, this is the book as it will look in the physical copy as well. This is a PDF. Let's get into it. The structure of the different chapters are remind of each other. There's an introduction explaining the topics that we're going to discuss. Then there's some technical requirements, and then the main content of the chapter divided into a few sections, and then finally a summary, conclusion with a summary discussing what we learned and what's in the next chapter, things like that, maybe referring to later chapters for in-depth explanations of some of the topics that we touched on. For example, in this one, it mentions Aot compilation, and there's an entire chapter about that that we just discussed. Anyways, let me try to read this. I'll need some water first. And remember, you can read this chapter 2 for free as well on the product page on packpop.com for this book. So across data binding and attribute directives, there are many options to dynamically change styles in an Angular application. Angular Ivy supports multiple styling application programming interfaces, APIs, in a predictable way. This chapter teaches us about Angular Ivy's style binding precedence rules through a simple example that uses almost every possible style API in Angular. Through a few examples, we will explore how directive and component inheritance and the sharing of metadata have changed in Angular Ivy. Before that, we learned which metadata properties are shareable through inheritance. So those are a few interesting topics, I hope. The ahead of time compilation was introduced in one of the first major releases of Angular. Angular Ivy is the first generation to enable it in all phases of the application lifecycle, from development through testing to builds. And there's a here, just zooming in a bit more or removing some tooling. Okay, we will discuss how this affects our workflow and bundle size after briefly peeking under the hood of Angular to discuss some of the internal building blocks that have enabled the performance improvements needed to make this change. The strict mode preset available with Angular Ivy enables additional compile time checks of our Angular applications as well as bundle optimizations. Angular Ivy and its supported versions of TypeScript have added significant speed improvements and stricter checks to tests. We'll learn about this through examples that are easy to understand. Angular's compiler analyzes our application code at build time. This is nice, but some of the compiler error messages suffer from missing context. That's speaking of the view engine error messages. In Angular Ivy, contextual details have been added to several compilation error messages. In this chapter, you will see Ivy compilation error examples compared to compilation errors from earlier generations of Angular as we discuss how it improves the developer experience. Yeah, this is an area where the later versions of Angular has really improved a lot. I know Joost Kuhorn from the Angular team has been working a lot of these error messages and improved them in each major version, or even some feature versions. So a big round of applause for that. They are very, very helpful compared to early on. That also goes for the strict template type checkings. That's also discussed in this chapter. And yeah, all the error messages for that, they are extremely helpful. Whereas in View Engine and template compiler generation of Angular, error messages were a bit more mysterious and lacked a lot of context about where did this error occur and what does it mean and how do you fix it. To the point that now today we have ng error codes for many of the compilation errors, and there are even videos on the Angular.io website explaining about those errors and what to do about them. Okay. Angular is known for great tooling and support for strong typing through TypeScript. However, we have not been able to type check all parts of our component templates in the first or second generation of the Angular framework. That's the template compiler and the View Engine generations. The Ivy generation completes the component template type checking story for the Angular framework. That's with the strict template type checking. Automated migration schematics are a wonderful piece of tooling that is part of the Angular framework. Since Ivy was released, they include messages with descriptions and an option to run them in separate commits, as we will see in this chapter. The versions of the Angular language service introduced with Angular Ivy have allowed for better integration with IDEs such as Visual Studio Code. Additional tooltips are added to component templates, and additional details have been added to existing tooltips. Syntax highlighting has been added to inline templates and improved for external file templates. We're going to see some screenshots. I hope they're in color in this PDF. They're not in the printed copy of the book, but in the GitHub repo, all the images are available in color as a downloadable zip file. But yeah, there will be color screenshots of some of these errors and tooltips and things like that. In the second chapter of the book, we're going to cover these topics: using predictable style bindings, sharing metadata through directive and component inheritance, outputting faster and smaller bundles with Aot compilation, taking advantage of strict mode, and other new configurations. Also, enhancing our Angular testing experience and leveling up our developer experience. So after finishing this chapter, you can boost your developer productivity by taking advantage of the latest improvements in tooling, configuration, and other Angular features. Now comes the technical requirements. They're specific to each chapter, so it doesn't go into detail about which feature requires which version of Angular TypeScript. It's kind of a minimum version that supports all the features and tooling explained in each chapter, or in this chapter in particular, although in some sections, in some chapters, specific versions are mentioned. For this chapter, some of the features or tooling requires Angular 12.0 and TypeScript 4.2 at the very least. And then there's a link to this GitHub repo even pointing to the two feature apps in chapter 2. So we'll look at that when, let me just find it and we can see which feature apps are in there. Okay, going out to the code, we have an Angular CLI workspace with many different apps. So chapter 2, there's one for inheritance and one for style bindings. So there we go. And we'll look at each one after reading the section they cover. Okay. Let me scroll down a bit. So using predictable style bindings. Oh, Oscar has a question. Can you share those video links? So you must be talking about the NG errors. Well, let's see if we can find an example. If I search for, I have to zoom in here so you can see it. Let's search for NG101. I think that's an error message. No? NG110. What's that error message? Isn't it like... Oh, okay. Yeah, okay. NG0100. Expression has changed after it was checked. This is the most dreaded error message of Angular compilation. And here's a video by the Angular team explaining this error. So now you'll get an error message with this code, so you can go and look that up in the Angular documentation, and there's a video explaining it. There's a description and debugging instructions. So, of course, this is another part of Angular Ivy that has been improved a lot. The documentation, ever since Dave Shevitz joined as kind of the lead, taking the lead on the Angular documentation. And I know they have several people working on it now full time. So he's done a lot to restructure, reorganize, and improve almost all parts of the Angular documentation at this point. So huge shout out to Dave. All right. Going back to the book. We're going to discuss using predictable style bindings. Angular has many ways to bind styles and classes to the DOM elements. Ivy introduces predictable style bindings because of a precedence rule set that covers all of Angular's style binding APIs except for the ng class and ng style directives. And then a fun fact. Now I guess that's in the next paragraph. Template element bindings have higher priority than directive host bindings, which have higher priority than component host bindings. Binding of individual CSS classes and style properties have higher priority than binding maps of class names and style properties. Binding values that define the full class or style attributes have even lower priority. The ng class and ng style directives override all other bindings on every value change. Bottom values in style bindings are treated differently. Binding the undefined value will defer to lower priority bindings, while null will override bindings with lower priority. And this sounds complicated, and let's see what it's all about with an example here. So we have an app component, and it's using some component called app host binding. There's an ng style binding. There's a what's that called? The template property binding, style binding, I think, and template map style binding, and then the static style template style binding. Then on this component, we're also applying a directive called app host binding. So this component will have some style bindings. They will be overridden by the style bindings in this directive. And the ones that we have inline in the app components template, they will override the equivalent bindings here in the component and the directive bindings. So pink, red, orange, yellow, blue, purple, gray, green. Yeah. So which color does this one have? Here in the directive, we have some host style bindings. There's the directive host property binding and the directive static directive host style binding. In the component, we have the component host property binding and the component static style binding. So the question is, which color will this element have, which background color, if we put it into an app? And I created a talk about this, going into even more detail. Let me see if I can find it here. Speaker deck. Yeah, this one. Confidence in templates and styles with Angular Ivy. So this is a full talk covering strict template type checkings, going into examples and discussions about each strict template type checking rule. And then also this style precedence rules. And there's somewhere in here, there's a demo for style binding that we can look at. Here it is. No. I have to copy this, I guess. Stackblitz, edit Angular Ivy style binding precedence. That's the URL. So let me post that one, that Stackblitz, in the chat here, and let's have a look. There's the app in the repo is very similar. The feature app for this chapter is very similar to this one. So here, right now, the background color is, hey, stop doing that. Background color is crimson red because we're using ng style, and you might remember that. Wonder what's best, dark or light. We'll use dark. This is Angular after dark. Okay, so ng style always overrides every other possible style binding. It's the exclamation mark important CSS rule, but for Angular style bindings. So when we remove this, another color will turn up, and I wonder which one it is. It will probably be hot pink because this has the highest priority or the highest precedence of all the different style bindings used here. Another, well, let's check. Yeah, now it's hot pink. And another thing to know is that the ordering of the style bindings doesn't matter anymore. So moving down here, it's still hot pink. The type of style binding is what matters, and that's what the precedence rule set is defining. So removing hot pink, and we'll have a coral background color. That's the next precedence that we have applied. And removing that, we have the template static style binding, which is gold. Removing that, and then what's the most important thing after the template style bindings? Well, it's the directive host bindings are more important than the component host bindings. So we'll have to look into the directive here. And we do see that there's a directive host property style binding here with Rebecca Purple applied. Rebecca Purple is named after Eric Meyer's daughter, who passed away to cancer some years back. And it's this beautiful, rich, deep purple color that I really, really like. Anyways, removing that, and we'll go to olive green. And that was the final ones of the host style, host directive style binding. So we might as well remove that and remove from here. And this doesn't really change anything. Oh, Something happened here. Oh yeah, there was probably an ng module somewhere. Okay. So now the only thing we have left in our template is this app host style component. So let's look at its style bindings. It has this component host property style binding of navy blue, as we see here. Removing that, we'll move to the tan. This is a static component host style binding. And that was the final one. Removing that, and there's no background color left. I have a style somewhere which makes it white or transparent or whatever. So it's here, but you can't see it. That was the demo here, and this, if you go look at this talk, confidence in templates and styles with Angle Ivy, the slides I just posted here, there's in the description, there's a recording, or even two, I guess, of this talk. And I recommend you go and check that out. It goes a bit more into the practical side of more examples than the book actually does. But of course, it was inspired by the book. Actually, it was Armin Vadanyan who I proposed to pick 2 topics from the book, and these were the ones he found most interesting: strict template type checking and style binding precedence. So then I created this talk. Okay, so this is a very similar example we have here in the book, in this chapter. I won't read all the code again, but in the preceding code example, we see components and a directive using many different types of style bindings. Despite this, it will output only a single style rule to the DOM for the app host binding element. The background color of this rule will be evaluated as pink. And this is what's important to be aware of. Despite all these style bindings apply to the same DOM element, only one style will be output at runtime. And this is evaluated by Angular at runtime and changing as the bindings change, because here we have values, but it could be tied to variables that are, or properties that are changing based on some conditions or events happening. So they can change at runtime. There will always be one value for each property added by Angular at runtime. All right. The order in which the background colors are applied is shown here, with the highest precedence first. Pink. So it was the pink color because of the ng style directive binding. If we remove that, it would have been red because of the template property binding. Then orange because of the template map binding. If we remove that, it would become yellow because of the static style value. Removing that, it would become blue because of the directive host property binding. And after that, it would have been purple because of the static directive host style binding. Then gray, which is a component host property binding. And finally green because of the static component host style binding. As seen in this example, the order in which the bindings are mentioned in templates and metadata options does not matter. The precedence rule set is always the same. So we can change all these bindings, the source order, and it won't matter, with a single caveat that I hope I mentioned in the book. Having predictable style bindings makes it easier to implement complex use cases in our applications. It is worth mentioning that another reason for introducing this breaking change is that Ivy does not guarantee the order in which data bindings and directives are applied. And this is one of the reasons for this change. Because in View Engine, order of the bindings and the directives and all that, the source order mattered. But Ivy will no longer guarantee that order, that it's applied in the same order as it's described in the template. So the That's the reason for making it predictable with these precedence rules. Before it was a bit more unclear and probably not documented at all or very well. And a very happy accident of creating these style precedence rules is that now we have support for CSS custom property bindings in Angular, and that's covered in, I believe it's chapter 3 or something like that. Hello, Mr. 1. Is there an Angular 13 migration on NX 13? Not yet, but it will come in an 13.x NX release. So it's written as part of the NX 14 roadmap, but the Angular 13 migration in itself will be released as a major version of NX. Sorry, a feature, a minor version, a feature version. So it will be 13 dot something that will contain the Angular 13 release, 13 dot something of NX. Okay. So in this section, we witnessed the following styling precedence rules in effect, from highest priority to lowest: template property bindings, template map bindings, static template class and style values, directive host property bindings, directive host map bindings, static directive host class and style bindings, component host property bindings, component host map bindings, static component host class and style bindings. This is the precedence rule set of Angular Ivy. You're welcome, Mr. 1. The order in which style bindings are listed in code only matters if two bindings share the same precedence, in which case the last one wins. So we saw that if I switched around the style bindings, it didn't impact the value because the precedence were different. But if there are two bindings with exactly the same precedence, the last one declared in the source order wins. These precedence rules are also visible in the Angular documentation. Let's see if we can find them. And of course, this is where I got the inspiration from. Style precedence. If we search for that, we shall find helpful information in the Angular documentation. So here, it's also explaining these 3 different layers. So we have template bindings, directive host bindings, and component host bindings. And examples of each type of binding. And what else? Something about specificity. Yeah, okay, so it's covered by Angular documentation. I covered it in a different way in my book, and with this example that's now in a stack blitz. And I also discuss it even more in detail in that talk called Confidence in Templates and Styles with Angular Ivy. Okay, so last important learning here. The ng class and ng style directive bindings override all other style bindings. They are the important equivalents of Angular style bindings. So use them very sparingly. They should be a last resort. There's an order to this madness of many different style binding APIs. So try to figure that out first. Same as trying to win the specificity wars. You should understand it and keep the lowest specificity possible. That will override the styles when dealing with CSS, instead of using important keyword in CSS, because that won't make it any easier. So same thing here. Avoid ng class and ng style. It used to be the case that they could express some style bindings that you couldn't do with any other style binding API, but that's no longer the case. The only reason to use them is to override everything else. Shouldn't be used for anything other than that, and even that shouldn't be done very often. So try to avoid that. Now that we can predict how multiple style bindings and values affect our UI, let's look at how we can use class inheritance to share directive and component metadata. So that was all about style binding precedence, and now we'll look at inheritance. I don't recommend using inheritance very often, but if you do in Angular, this section covers what can be shared, the metadata options for components and directives that can be shared, because this changed as well in Angular IB, and they added like optionless decorator factories for ng module and directive. I think component still needs at least a template or it won't render, but you can, if you have a base directive or base component, maybe you can then apply an empty directive decorator. I don't know for sure. Or you can just add a component decorator with an empty template. Anyways, I thought that this was interesting to explore more in detail what can and cannot be inherited of all the different directive metadata for directives and for components, because this is something I'm not sure is covered at all in Angular documentation. There's some migration guides for IB mentioning why and how we apply the directive and component decorators to base classes, because it is a breaking change. In some view engine base classes, you didn't have to add the directive and component decorators and even the injectable as well. But now, every time we use a feature, as we'll see, a specific feature of the framework, we have to add that. We have to add that one of those decorators. All right. So sharing metadata through directive and component inheritance, that's this next section. Angular IB changes directive and component inheritance in a more explicit but predictable manner, which allows the bundle size and compilation speed to decrease. So yeah, this is one of the reasons for this change, is that it was difficult for the compiler to figure out things like dependency injection and adding annotations on the classes when there were no decorators on the base classes. So now we have, when we're extending a class, the base class also needs to have a decorator, and so does the subclass as well. When a base class is using any of the following Angular-specific features, it has to have a directive or component decorator applied. So that could be the dependence, a dependency. So any, this is, I think, I hope I changed this in the actual book. This might not be the final version of the PDF, because it's kind of, this is a misunderstanding by a reviewer or a proofreader or something. There's no dependency decorator. What I mean here is, if you inject a dependency in the constructor, you have to apply the directive or component decorator. But the attribute, that is a decorator. You don't see it used very often. But this is, instead of having an input property, we can pass a string as kind of an attribute on a custom element, and we can inject it directly in the constructor. But then it won't, we won't be able to change that value. But that's the same with a custom element and an attribute, whereas an input property of a component is more like a property on a web component, a custom element. So if we're using dependency injection, or we're using an attribute decorator on an injected parameter in the constructor, then we have to apply directive or component decorators. If we have an input or output property in the class, we also have to have a directive or component decorator now. And the same goes for the host binding or host listener bindings. Also, Same goes for view child, view children, content child, and content children queries. As soon as we're using any of those, we have to add the directive and component decorator. So to support this is new in Ivy, we can add a directive decorator without any options. So just the @ sign, then directive, and then parentheses with no arguments. This conceptually works like an abstract directive and will throw a compile time error if declared in an Angular module. So base directive or base component classes shouldn't be or cannot be declared in an Angular module. Only the subclasses extending that base class. Well, a directive without any options. If you try to add that to the declarations array of a module, a compile time error will be thrown. So we could make these base class, the base class abstract, the abstract keyword, but that will cause to have us to extend it to test it. So there's a trade-off there. By extending base directives, we can inherit the inputs, outputs, host, and queries metadata options. Some of them will even be merged if declared both in the subclass and the base class. Components are able to inherit the same metadata options from their base class, but are unable to inherit styles and template metadata. It is possible to refer to the same style URLs and template URLs, though. Also, a template can be, if you use an inline template rather than an external file, you can share, let's say, part of the template could be in a variable shared between two component templates, or even the full template can be just in a string variable, but it has to be static. It cannot be lazy initialized or asynchronously initialized, because declarables have to be resolved at compile time. Otherwise, we cannot use Aot compilation, and everyone should be using that now for all their Angular applications. To the point that the Angular team is considering removing JIT compilation entirely. So if you're not on Aot compilation yet, go ahead and make that effort, and it'll also be worth your while in many ways. Okay, so the book then reads, let's write some example components that share behavior through a base class. First, we will create a base search component as seen in the following code snippet. Then some imports here. A component which has the selector app base search. It has a template which is empty. The class is called base search component. It has a native private member with the hashtag in front of it, or the pound sign. So hashtag search is a new event emitter of string. So this is an alternative, or the standard way of adding private members to classes. This is almost finalized in the ECMAScript standard, and also as of the very recent versions of TypeScript, it's properly supported for methods, properties, static methods, static properties in TypeScript classes. But it is an alternative to the private keyword, the private access modifier of TypeScript, where the private keyword, the private access modifier, is only private at compile time. This hashtag, the native private class members, they are actually private at compile time. No, sorry, at runtime. So they are truly private, and instances of the same class, I don't think they can even access each other's, which is a kind of a strange feature of most programming languages that private members can be accessed by other instances of the same class, which is kind of strange when you think about it. I don't think that's the case with JavaScript private members, but I'm not 100% sure. Okay, so we have a private search event emitter that will emit a string at some point. We have an input property called placeholder. It has a default value of search ... We have an output property called search, and it's piping on that event emitter called the private search field. And we use debounce time with 150 milliseconds and then distinct until changed, so that we're waiting for keystrokes to hold a pause before emitting a search term. Also, we won't re-emit the same value twice, 2 times in a row. We then have an event handler called onSearch. It accepts an input event. So we're then the input event's target, which is expected to be an HTML input element. We're unpacking the value of that and storing it in the query variable or constant variable here. If query is null, we will do nothing, so return. But if it is a string, we will emit it through the private search event emitter, which will then be piped through the debounce operator, the distinct until changed operator, and out through the output property called search. And that was it for the base class. The base search component has an event handler that handles input events representing a search query. It debounces searches for 150 milliseconds and ignores duplicate search queries before outputting them through its search output property. Additionally, it has a placeholder input property. So you might have noticed that this base class doesn't have a template, so it won't do anything. It won't even bind to all of these. And it's not meant to be used on its own either. It's meant to be extended, right? That's why it's called the base search component. So next, we will create a simple search box component that inherits from the base search component. This is seen in the following code snippet. So importing the component decorator, importing this base search component from another file, and then this is a component with the selector of app search box. It has style URLs, and look at that. It uses base search styles as well, so they are also shared between this class and another class probably. Then we have the template inline. It has an input element of type search, and then it binds with the property binding, it binds to the placeholder property, which is a property in the base search component class. But since our search box component class extends that, it will also have a placeholder property, which is actually an input property. Then similarly, we bind to the input event on this input element, and we pass it to the message handler, the event handler called onSearch, which is also part of the base search component class. So looking at this final line here, no properties, no methods are defined in this search box component class, but it's binding to the onSearch event handler and the placeholder input property that comes from the base search component. And interestingly, it's sharing some styles from base search sassy styles as CSS. Yeah, so the search box component uses base search styles and can add its own component specific styles if it needs to. Then we would add a comma and list a file with styles exclusive to this search box component. Okay. The input element in its component template binds to the placeholder input property it inherits from the base search component. Likewise, the input event is bound to the onSearch event handler that it inherits. So let's create another component that inherits from the base search component. The following code block lists the suggested search component. It's called the suggested search component. So importing component, also this time importing the input decorator, and then importing the base search component. And let's look at this class. It has a selector called app suggested search. It also uses these base search styles. It has a template with an input element and this HTML5 data list element, which has some options in it. So this is an auto-completion set, data set, that will be this one. These are the autocomplete options that are bound to this input element by adding the list attribute and then specifying the ID of this data list. So down here, I'm not sure if you've seen this before, but this is part of HTML5. So it's a native autocomplete, but we're using Angular to fill in the options here. So looping over suggestions. For each suggestion, we're adding an option element with the value bound to the suggestion, and then also the suggestion is displayed. All right. So the class is called suggested search component. It extends the base search component, and it adds an input property called suggestions. That's a read-only string array that's initialized by default to an empty array. In addition to the inherited input property placeholder, the suggested search component adds a suggestion input property, which is a list of search query suggestions. The component template loops over these suggestions and lists them as option elements in a data list element that is tied to the input element. Similar to the search box component, the suggested search component binds to the onSearch event handler and the placeholder input property. It also uses the base search styles. Then an important note, as seen in these examples, we do not have to add duplicate constructors in subclasses to enable constructor injection. I'm not sure, but I think in View Engine or at least some earlier versions of Angular, you had to add a duplicate constructor to enable a dependency injection. It might have to do with the fact that you could not or did not have to add a decorator to the base class. Or maybe it was the other way around. Maybe the subclass? Nah. Anyways, now we know the rules as listed in the introduction to this section. Every time we're using some of these Angular decorators or features, we have to add a directive or component decorator to the base class as well as the subclasses. Okay, but yeah, importantly, we do not have to add duplicate constructors. So here the suggested search component does not have any constructor. It's inheriting the one from the base search component because we don't need additional dependencies. If we did need additional dependencies, we would have to call super and pass the dependencies required by the base search component class. Right. Directive and component metadata is the special glue that ties TypeScript classes to the DOM through component templates and data binding. Through classical object-oriented programming patterns, we are familiar with sharing properties and methods through class inheritance. In this section, we learned how Ivy has enabled us to share metadata in a similar, predictable way through metadata-enabled class inheritance. That was all for this section. The next topic we are going to explore is Aot Compilation. Ivy heralds the era of Aot compilation everywhere in Angular applications. All right. Next section. outputting faster and smaller bundles with Aot Compilation. Angular Ivy is first and foremost an internal rewrite of the Angular compiler, the Angular runtime, and a few more pieces of the framework. A lot of effort was put into maintaining backward compatibility with application code written for the Vue engine generation of the Angular framework, that is version 4 through 8. And yeah, even up to recently, Vue engine was still supported. I think it's 12 or 11. One of those is the last. I think 12 is the last major version of Angular to support Vue engine. In 13, it's not available anymore. The only exception there is you can still use Vue engine compiled libraries by using the Angular Compatibility compiler. That will be the case for a few major versions, but we should start migrating our libraries to partial Ivy compilation, but that will break compatibility with earlier versions of Angular using Vue engine. So it's a trade-off, and we have to make sure to explain it well in the documentation of our Angular libraries. Okay. At the heart of this new generation is the Ivy instruction set, which is a runtime DOM instruction set similar to the incremental DOM library, also by Google. In a nutshell, an Angular component is compiled into two lists of instructions that, when executed by Ivy, will initialize the DOM with the first list of instructions and update the DOM with the second list of instructions whenever changes are detected. The Ivy instruction set is lighter than the Vue engine equivalent, which the runtime had to translate before applying it. In Vue engine, it used to be the case that a large Angular application would eventually have a smaller JIT compiled bundle than the Aot compiled bundle for the same application. With Ivy, this is no longer the case. For small Angular applications, Ivy adds the benefit that the Ivy instruction set and the individual parts of the runtime are tree-shakeable. This means that we are not paying for the parts of the framework runtime that we are not using, in that they are removed from the output bundle. For example, Angular's animation and globalization APIs are not part of our application bundle unless we are using them. This is very important in micro frontends and web components where we need to minimize the overhead of the Angular framework. Angular version 11 is the final major version supporting Vue engine. Okay, so that answers my question. Unless this is not a final version of my book, because I did double check facts like this version specific thing. So let me check in the book for the definitive answer. So it should be on page 42. Right. Yes. Okay. It says the same thing. So Angular version 11 is the final major version supporting Vue engine. I don't feel 100% sure of that. I thought that version 13, which was recently released, was the first one to entirely remove Vue engine. But I think I double checked it when finalizing this book. So the book says 11, but yeah, I'm not 100% sure. I'm not 100% sure, but okay, there are more details like this. So Angular version 11 is the final major version supporting Vue engine. The Ivy instruction set is kept as a code generation API, meaning that our code should not rely on it. So the actual Ivy instructions. Angular libraries supporting Angular versions 9 to 11 are not recommended to ship Ivy compiled code. Instead, the Angular Compatibility compiler is used to transpile the Vue engine compiled libraries to Ivy. Unfortunately, this means that our initial build time increases as the Angular Compatibility compiler must compile each Angular library entry point in our node modules folder. This is especially hard to manage in managed build pipelines, Read about the Angular Compatibility Compiler in Chapter 10 called Using the Angular Compatibility Compiler. So yeah, there's an entire chapter explaining the Angular Compatibility Compiler, all its parameters, and how to optimize it for local development, for CI/CD pipelines, and for monorepos as well. So that's Chapter 10 of the book. As of Angular version 12, it is recommended for Angular libraries to ship partially Ivy-compiled bundles using the Ivy compiler. This means that our application can more fully enjoy incremental builds that speed up the overall build time. This is because of an Ivy concept known as the Principle of Locality. The Ivy compiler only needs to know about the public API of, for example, child components, rather than having to know about their injected dependencies and mention them in the compiled output of the parent component. In general, Ivy results in decreased build time, except for the time it takes to run the Angular Compatibility Compiler on Angular libraries, including the Angular Frameworks packages themselves. Yeah, you heard right. The @Angular packages are compiled with Vue Engine, which means they have to go through NGCC, which means things are very slow, especially the Angular material packages. So maybe that has changed in version 13. I'm not sure, but that would be great. As we discussed, using the Ivy compiler also results in decreased bundle sizes overall. However, if we are using most parts of the framework runtime, our main chunk's bundle size might increase, while the size of lazy loaded chunks decreases. With the introduction of Angular Ivy, we can now use Aot compilation during all phases of development. This removes subtle but important differences between development, testing, the build process, and the production runtime. The short explanation in this section is just enough to give us an overall idea about the effect that Aot compilation has on Angular applications. However, this book is a practical approach to developing Angular Ivy applications. In everyday development, we do not have to be familiar with the internals of the Angular compiler, the rendering engine, and the runtime. But you can read more about the impact and limitations of Angular's Aot compiler in Chapter 12 called Embracing Ahead-of-Time Compilation. Yes, there is an entire section, as we discussed and as recommended by Oscar, just about the Aot compiler and its limitations. There are not many anymore, but I remember when it was introduced in Angular 4, there were a lot of limitations, so it was not easy to migrate. But only few are left now. Most of them are not limitations anymore, or you can add strict template compilation, strict template type checking, and strict TypeScript compilation to detect things that are limited in Aot compilation and fix it. Okay, in the following section, the next one, we look at the compilation presets and configurations introduced by Ivy and its accompanying TypeScript versions, because you might know that each major and even each minor version of Angular supports 1, 2, maybe 3 types of or versions of TypeScript. Let's look at that. I happen to maintain an Angular compatibility matrix. I will add that to the comments. Zoom in, please. There we go. So here's the gist. And this is a compatibility matrix between Angular CLI, Angular Node.js, TypeScript, and RxJS versions that I've maintained for a few years. It's based on changelogs, hands-on experience, and metadata. Note that major Node.js and RxJS versions above officially supported versions are not listed. And important notice, minor TypeScript versions also contain breaking changes. I think I've only seen one new version of TypeScript that didn't contain breaking changes. So TypeScript doesn't use semantic versioning. It uses marketing-driven versioning. So whenever they feel like, oh, it's probably time for a new major version, they will release a major version. A minor version contains breaking changes, and that is why any minor version of Angular will support just 1 or 2 or 3 versions of TypeScript. But it's also interesting that supporting a new minor version of TypeScript is not a breaking change, although there are breaking changes in between 2.3 and 2.4 of TypeScript. So Angular doesn't really have full semantic versioning as well, and they don't have any migrations to switch between versions of TypeScript either. So that's something you should be very aware of. You might see a compilation error when upgrading to a new feature version, a minor version of Angular, and it could be because of breaking changes in a new version of TypeScript supported by that version of Angular. Luckily, every version of TypeScript comes with a blog post, an announcement that discusses these breaking changes. So something to be aware of. Let's look at the recent versions down here. So Angular 13, which was recently released. This is the Angular CLI version, 13.0. And the Angular version 13.0, it supports 3 major versions of Node.js, 12.20 or later minor version, 14.50 or later minor version, and 16.10 or later minor version of Node.js. And this is TypeScript. It only supports TypeScript 4.4, which is the latest one. But it also supports RxJS version 6.5 or 6.6 or even 7.4 or later minor version. And this is actually, I think, is this now the default version of RxJS when generating a new workspace? It might be, yeah. But of course, there are breaking changes between RxJS 6 and 7, and there are no automated migrations. So but there's a long list of the breaking changes on the RxJS website. So a guide to migrating manually, kind of, or at least what to be aware of. Okay, enough of that. Enough of that. Okay. Taking advantage of strict mode and other new configurations is the title of this section. Angular has always been big on tooling. Ivy adds and enables additional configurations that help us catch errors early and output smaller bundles, such as strict mode. When we create an Angular workspace using the ng-new command, the --strict parameter flag is on by default as of Angular version 12. I don't remember exactly when it became available, maybe in version 10 of Angular or something like that. But it was not the default option until Angular version 12. When we use the strict workspace preset, it enables additional static analysis. The --strict parameter flag is also supported for project generation schematics, such as ng-generate application and ng-generate library. The strict preset sets the following TypeScript compiler options to true: force consistent casing in file names, no implicit returns, no fall-through cases in switch, and strict. And the strict option is a preset that involves many other strict settings, but also any future strict compiler setting for TypeScript. So setting that to true will keep the best static type check experience for our application. These options help us catch a lot of potential errors at compile time. Refer to the TypeScript documentation for details about the individual compiler options. The strict TypeScript compiler option is a shorthand for enabling all the following compiler options as of TypeScript version 4.2. Always strict, no implicit any, no implicit this, strict bind call apply, strict function types, strict null checks, strict property initialization. And additionally, future strict TypeScript compiler options will be enabled automatically when using the strict shorthand. Bundle budgets are reduced in strict mode. The initial bundle warns at 500 kilobytes and errors at 1 megabyte, while component styles warn at 2 kilobytes and error at 4 kilobytes. Strict mode further enables strict template type checking, which we'll cover later in this chapter. Now for Angular compiler options added in Ivy. Only a few Angular compiler option defaults have changed in Ivy. In Angular version 9, the default value of the Enable Ivy option was set to true for applications but false for libraries. This changed in Angular version 12, where the Enable Ivy option was removed entirely when View Engine support was disabled for Angular applications, and the partial value for the compilation mode was added for partial Ivy compilation of Angular libraries. The strict templates option is introduced with Ivy. Its default value is false, but it is set to true when generating an Angular workspace by using the ngnew command, which enables the -- strict parameter flag. The same applies to the full template type checking option, which is implicitly set by the strict templates option. So setting strict templates to true also enables all the rules that were previously available in View Engine that were known as the full template type checking. The default value of the strict injection parameters and strict input access modifiers options is still false, but it is set to true when generating an Angular workspace by using the ngnew command. Now that you are aware of the many helpful configuration options introduced by Angular Ivy, you can gain more confidence about how your Angular applications will behave in production runtime. Next up is a favorite topic of ours, testing. That's me and Jacob. Both Ivy and its related TypeScript versions introduce substantial improvements to the Angular testing experience. And yeah, I think I wrote an article about this at some point. Angular 9 testing something. What was it called? Lars. Yeah, here it is. Next level testing in Angular version 9. I'll write it in the comments as well. Here it is. So this was an article. I published it January 27, 2020, because it's about all the new additions to the very first version of Angular Ivy version 9. All the new additions to testing and improvements. So Aot compilation tests, finally. Faster builds for tests. Faster tests, stronger typing, and a new concept called component harnesses. And all of this is covered in the book in even more detail. So, enhancing our Angular testing experience. Ivy is a major milestone for Angular tests. Besides the stronger typing and tests discussed in Chapter 1, discovering new APIs and language syntax, it adds major speed improvements and useful test utilities, one of which is component testing harnesses, which we will cover in Chapter 4, exploring Angular component features. Angular components features. Angular components is one of the Angular teams that developed the Angular material, Angular CDK, and the Angular Google product packages, such as Google Maps for Angular and the YouTube player for Angular, that are also covered in Chapter 4. In this section, we explore how we can introduce values of unexpected types using a TypeScript annotation, which proves to be useful in tests. After that, we discuss another important aspect of Aot compilation in Angular Ivy. Expect error compiler annotation. TypeScript version 3.9 introduces a special compiler instruction comment that is useful in tests. The add ts-expect-error annotation comment allows values of incompatible types to be passed to functions in the following statement. As an example, let's write an add function and verify that it rejects strings, even at runtime, for robustness. So here we have a function add. It has the first parameter called left, which is a number, and then right parameter, which is also a number, and it returns a number. It calls assert is number on the left parameter, assert is number on the right parameter, and then finally it returns left plus right. The robust add function in the previous code snippet applies an assertion function for both operands, the left and right operands. Let's test that an error is thrown if strings are passed as follows. So now comes the test suite. Describe add. It rejects a string as left operand. First we assign a constant called text input. We have the string value of 2. Then we assign a constant value variable 4 with the number literal 4. Now we add this add ts-expect-error annotation so that we can pass a string parameter as the left operand of our add function. So now we expect that calling add with the text input and the 4 variables passed to throw. And the next case here is it rejects a string as the right operand. That's the second test case. So we have the constant variable 3 with the number literal value of 3. Then we have constant text input, which has the string value of 5. And now we again use the add ts-expect-error annotation to allow for compilation errors. To expect that calling add with the 3 and text input values passed will throw an exception. If we remove the add ts-expect-error comments, the TypeScript compiler throws errors because of the incompatible values we pass in the tests in the previous code block. How is this different from the add ts-ignore comments? Well, the add ts-expect-error comments warn us if a compilation error is not thrown in the statement that follows. This raises our confidence in the code. Next section here, faster tests with Aot Compilation. Angular Ivy introduces Aot Compilation to tests. This makes the test environment close to the production environment, which is a good trait as it allows us to catch errors early. Until Ivy, Angular had a long-standing issue of relatively slow tests when they involved component tests using testbed. The tests were slow because the test runner was reading, parsing, and compiling one or more files for every component per test case, not per test suite, not per test run. Ivy introduces the principle of locality as well as cache for compiled declarables and Angular modules, which speeds up component tests significantly. Additionally, rebuilds are faster, which improves speed when writing tests and fixing bugs. With these pieces of valuable information, you now know how Ivy can greatly impact your developer workflow when implementing unit tests or component tests especially. As mentioned in the introduction of this section, we have saved one of the most exciting features for Chapter 4, exploring Angular components features, namely component testing harnesses. But for this next section of this chapter, it's all about how Ivy boosts our productivity by improving the Angular developer experience. Moving on. Leveling up our developer experience. Ivy improves the developer experience in many ways. In this section, we'll learn about the most noteworthy of them. Improved compilation errors. Compile time errors are a positive side effect of Angular using an Aot compiler. However, some of the build errors have needed additional context to aid in pinpointing the source of the error. As an example, look at the error message in the following listing that is output when using an unknown element in an Angular application that uses View Engine. So it reads, error in app header is not a known element. 1. If app header is an Angular component, then verify that it is part of this module. 2. If app header is a web component, then add custom element schema to the ng module schemas of this component to suppress this message. Error, app header. My contact. Which component has the error? How do we fix it? The next listing shows the error message that is output for the same mistake in an Angular application using Ide. Error in source app component HTML, column 1, line 1. Error ng 8001, app header is not a known element. Okay, so let's put this to the test. Now we have an error code, ng 8001 or 8001. Let's search for that on the Angular docs. ng 8001, unknown HTML element or component. So there's not a video for this one yet, but there's a description. One or more elements cannot be resolved during compilation because the element is not defined by the HTML spec, or there's no component or directive with such element selector. This is the compiler equivalent of a common runtime error, ng 0304. Tag name is not a known element. Debugging the error. Use the element name in the error to find the files where the element is being used. Check that the name and selector are correct. If the component is from a different module or import, check that the component is exported from its origin module and imported into the correct modules? No, this is... I really want to submit a pull request to fix this typo. Should say start.module.ts file. Anyways, I'll do that at a later time, or you can do it. Just go ahead and press this button and you will open a pull request to this repo. Yeah. Okay, and declared in the import list. When using custom elements or web components, ensure that you add custom element schema to the application module. If this does not resolve the error, check the imported libraries for any recent changes to the exports and properties you are using and restart your server. Okay, so a lot of things to try out to try to fix this error. But additionally, look at this error message here. 1. If app header is an Angular component, then verify that it is part of this module. 2. If app header is a web component, then add custom element schema to the ng module schemas of this component to suppress this message. And then some additional context here. We saw already in the first line that the error is in this file, source app component HTML, line 1, column 1. But here we see exactly where the issue is. It's in line 1 of this file up here, and it's highlighted with this tilde. It will show up as an inline tooltip if we have the Angular IB language service installed and using, for example, VS Code. And it'll be highlighted here. But also if we compile it, we'll get this full error message. Then it goes to see how is this file, this template file imported. Well, it's important in this file, the source app component.ts. In line 5, column 16, we see that template URL is pointing to app component HTML, which is this file. So it's sort of a stack trace of this is where the error occurred, and this is the component model importing this template. And then finally, it's also underlining or highlighting this path here to show exactly where the import, the binding of the template and the component model happens. And then the final description here is error occurs in the template of the component app component. So we have many different pieces of knowledge to go and see where the error is happening. Say if we ran the ng build and we just got this error message, now we can see, oh, it's in the app component HTML, which is important by the app component, the app component TS, and which is called the app component class. So many good pieces of information, very good compared to the view engine equivalent, where there's an app header somewhere and we don't know which component it's supposed to use. All right. The file path of the component model and the component template files are both listed, as well as the line number and the content of those lines. It is now much clearer where the problem was encountered, a big win for developer productivity. Let's look at another example. If we accidentally add a duplicate comma to the imports array of an Angular module, as seen in the following code block, a build error will be output. So we have a bunch of import statements. Then we have an ng module. It declares an app component. It imports the browser module and then the common module. But look at that. In between them, there's two commas with nothing in between. And then we have the empty providers array, the bootstrap array with the app component bootstrap, and this is the app module class. So this is the error here. How on earth would we discover that? Let's look at the error message in View Engine first, I think. View Engine outputs an error message similar to the one shown in the following listing. Error in source app module TS 1127. Error during template compile of app module. Expression form not supported. Source app module TS 1127. Error during template compile of app module. Expression form not supported. Cannot determine the module for class app component in C project sandbox Angular CLI 8 app source app component TS. Add app component to the ng module to fix it. So that's all the information we get. Good vibes, Oscar. Okay, you're liking my robot voice for this compilation error. Okay, so we get the relevant files and line numbers, but the error description, expression form not supported, is not very helpful. Here's the equivalent error message output by Ivy. Error in project's second app, source app module TS, line 11, column 3. Error TS 2322. The type of common module, type of browser module, or undefined array is not assignable to type any array, type any, or module with providers array. The type of common module or type of browser module or undefined is not assignable to type any array, type any, or module with providers. The type undefined is not assignable to type any array, type any, or module with providers. That doesn't mean much, but now look at the error message here. So line 11 imports. This is the one having the error, and it doesn't point out exactly this this section right here where we have two commas, but at least it points us to imports is the metadata having the error. And then hopefully we can go in and figure out that this is where the error is. So in the previous listing, we immediately see that there's an issue in the imports array and that somehow an undefined value ended up in it. Context is provided, so the source code is output, and the error description is improved. I mean, it's not perfect, but it does state that there's an undefined value somewhere here. It's also, yeah, I don't know, here, mentioned here. So there are some hints here, and then most importantly, it's telling us that the error is in the imports metadata. All right. Finally, let's look at the improved description of an error triggered by a piece of code that is not statically analyzable as follows. So we import a component decorator. We create a constant variable called template, and we assign the value of location.href. So this is the URL at runtime. Now we declare this app component, and the template will be location href. Crazy, right? The template option in the previous example is not statically determinable because it relies on information only available at runtime. So here's the error message output by View Engine. Error in no template specified for component app component. In the previous listing, we see that the View Engine error message is for metadata that is not statically determinable. It tells us which component has an error, but it does not help us understanding how to fix it. The type information shows that location.href is of type string, so why does app component not have a template option according to the compiler? The error message output by Ide is a lot more helpful as seen in the following listing. Let's see, here it is. Error in source app component TS, line 8, column 3, error ng1010. So another error that we can look up in the Angular documentation. I won't do it for this one, but it says template must be a string. And then value could not be determined statically. And then line 8, template. This is in the app component, also in line 3, column 18. We see explicitly that line 3 here, this is the issue. Location.href is underlined, unable to evaluate this expression statically because location is defined by the DOM lib TypeScript definition. And then it says, a value for location cannot be determined statically as it is an external declaration. Means that this is a runtime value. We cannot access this value at compile time, and we have to be able to determine the template at compile time, not at runtime, when we're using AOT. Okay. So then there's an error here with the app component not listed in ng module, but it's because there's compilation errors in the app component. So the error message output by Ide doesn't just show us the line and expression that are not statically determinable. It goes one step further and shows us that the entire location object is non-deterministic at compile time. So very, very helpful for this very strange error. You can all read more about the AOT limitations in the chapter recommended by Oscar, chapter 12, Embracing Ahead-of-Time Compilation. You can go back to the beginning of this video where I read out and discussed the different sections of that chapter, chapter 12. A sip of water, then we'll continue. The next section is strict template type checking. And this is another topic that is covered by that talk I mentioned earlier. Confidence in templates and styles with Angular Ide. So just listing it here again in the chat. So here you'll find it's a talk that goes more in depth with style binding precedence that we discussed earlier, read in this chapter 2, and strict template type checking. So there's recordings here, 2 different recordings for this talk. I hope that they're both good. So, yeah. Anyways, now for the content of the book on this topic, strict template type checking. So View Engine had basic and full modes for template type checking. But Ide introduces strict template type checking. In addition to the full mode template type check, strict mode enables several checks outlined as follows. Property binding types are checked against their corresponding input property type. Property binding type checks are strict about null and undefined values. Generic types for components and directives are inferred and checked. checks the type of template context variables, including $implicit, checks the type of the $event template reference, checks the type of template references to DOM elements. Safe navigation operations are type-checked. Array and object literals in component templates are type-checked. Attribute bindings are type-checked. All of these checks were not possible in View Engine or Template Compiler. They are only available as part of Ivy versions of Angular, with Ivy enabled, of course. So was this introduced in Ivy 9 or 10? I'm not sure. Anyways, you have to add these. You have to add strict templates, set it to true, and a few other options. I go into the detail about all of them in that talk. If nothing else, go look at the slides. They're meant to be a quick reference to the different settings, and then they're discussed more in depth in the actual presentation. Okay. The strict check of null for property bindings is important for property bindings using async pipe, as it initially emits a null value. This means that input properties being used with async pipe must either have a type that includes null or use the concepts known as template guards and input setter type hints. Next section. And by the way, those are explained a bit more in the talk as well. Okay, next section is an even better update experience. As part of Ivy, the Angular CLI adds 3 improvements to the update experience. When running the ng update command, the Angular CLI first downloads the latest stable version of the Angular CLI and uses it, that latest version, for the update to take advantage of the most recent improvements. As part of the ng update command, automated migrations are run by the Angular CLI. For every migration, a message is shown, such as the example shown in the following listing. Executing migrations of package Angular core. Static flag migration removes the static flag from dynamic queries. As of Angular 9, the static flag defaults to false and is no longer required for your view and content queries. Read more about this here. https v9 angular.io/guide/migration dynamic flag. Migration completed. This migration, by the way, is discussed a lot in detail in one of the later chapters in the book, the ones about migrating to Ivy. Because even though it's an automated migration, this one is very special because it changed all the way in version 8, 9, and 10. Behavior has changed a lot, so it's important to understand what's going on there when migrating from 7 to 8 to 9 to 10 and so on. So finally, the --create--commits parameter flag is introduced in Ivy to create a git commit per migration to make it easier to debug the update process. We will cover the Angular update process in more detail in Chapter 11, Migrating Your Angular application from View Engine to Ivy. That chapter is not only useful when migrating from View Engine to Ivy, it's also a guide that lays out the entire process of maintaining Angular updates and some of its Angular's own dependencies and how to deal with those. And it goes into detail about both the automated migrations, what they're doing, and code examples, and also manual migrations that are recommended but not required yet, but you should do them to be future-proof. And also some optional automated migrations. So optional, they will not be applied without you opting into them, but they're mentioned there in that chapter as well. All right, another section of chapter 2. This is the one with the screenshots. Better IDE integration. Ivy introduces remarkable improvements to the Angular language service, which integrates with our IDE, such as VS Code. Template and style URLs are verified inline, as seen in the following screenshot, where an error is displayed. This is especially helpful when renaming components. So here, there's a tooltip. There's an error underlined in the template URL. The template URL value is app component HTM. So the tooltip, when hovering over this highlighted line with an error, says URL does not point to a valid file, ng. So this is an error from the Angular compiler or the Angular language service with the calls the compiler with the strict template type checks and other things like this one. All right, that was figure 2.1, invalid template URL error. So this was not possible in View Engine. So good luck finding this error. At least now it makes it very easy. Another neat improvement is that we can use the go to definition IDE command to navigate to component template or style sheet file. This makes it easier to work with one specific component. For example, I can highlight the template URL or style URL defined in the component model and I press F12 in VS Code, and then I go to that template or style file. Ivy versions of the Angular language service gives us an additional context and tooltips for component models. The following screenshot shows a tooltip for a child component element in a component template. In the tooltip, we can see the Angular module that declared the child component. In the example, we see the child component, a class, is declared by app module. So that's figure 2.2, ng module annotation in the component element tooltip. So this is in a component template. I'm hovering over a component element, the app child one, and then I see this is a component. Child component is the class name, and it's declared by the app module. That's very interesting. Okay, similarly, the tooltip that appears for a component model also shows the Angular module that declared this component, as seen in the next screenshot. Here we see that app component is declared by app module. Figure 2.3, ng module annotation in the component model tooltip. So hovering over app component, the model class here, we see that it's a component. App component is declared by app module. This is how it reads. So with Ivy, we can see method signatures in a tooltip, as seen in the following screenshot. This helps us reason about event handlers. So that is the description of figure 2.4, component method signature in the tooltip. So we're in a template. We hover over this add method or event listener, and it says it's a method on the heroes component class called add. It accepts a name parameter, which has to be a string, and it returns a void, so undefined. So that's hovering over an event listener of the component in its template. Very helpful. And we can also go to that method by right-clicking it and selecting go to or something like that, or pressing F12 in VS Code, for example. Ivy's Angular language service enables us to see type annotations of UI properties and the $implicit template reference. This allows us to get type information about an iterable UI property used with the ng4 directive, as seen in the following screenshot. So there this is figure 2.5, iterable UI property tooltip. So I'm hovering over the hero, which is defined by let hero of heroes. And we see that hero is a variable that contains a hero type. This was not possible in View Engine either, because it was not possible to get the type of the ng4 iterables. But that's not now possible with strict template type checking. Okay. The next screenshot shows how IB enables us to get type information about the named iterator template reference in each loop cycle. So similarly, if we hover over the heroes mention in the line 14, we see that it's a property of the component model. So heroes component dot heroes, and the type is a hero array. So that was figure 2.6, named iterator template reference toolset. Combined with strict template type checking, as described earlier in this chapter, this allows us to catch type errors in components early and consistently. The improved Angular language service released with Ivy adds syntax highlighting to the inline component templates and styles as seen in the following screenshot. This makes single file components easier to use. So this is an inline template and inline styles. We can see syntax highlighting. This was not possible with View Engine. It's only possible with the Angular language service in Ivy versions of Angular. So this makes it easier to use single file components that I tend to prefer myself. So thank you for that. But one issue is that certain extensions won't work, such as auto-completion in the HTML and the CSS. So that's a trade-off. But I really hate renaming components because you have to rename so many different files. So I really prefer single file components, even including a scam in the same file as well. So a single component Angular module, which can then be migrated later at some point, hopefully, to standalone components. All right, that was figure 2.7, syntax highlighting for inline component templates and styles. And it says that inline templates even benefit from the ability to add syntax highlighting to template expressions, also introduced with Ivy. Yeah, so that was not syntax highlighting, was and also maybe auto completion as well. Nah, probably just syntax highlighting was not possible in the template expressions, even in the external template files before in View Engine. Finally, Ivy adds support for style preprocessors such as Sass in inline styles by introducing the inline style language option to the Angular Dev Kit build Angular browser and the Angular Dev Kit build Angular Karma builders, for example, inline style language SCSS. Now for the summary. So we're at the final part of this chapter. Now we'll recap what we have learned. In this chapter, we learned how Angular Ivy boosts our developer productivity through even better tooling and predictable APIs. We started out by learning the many ways of binding styles to elements using Angular Ivy. Through a comprehensive example, we saw how the order of style bindings does not matter. However, we learned that the type of style binding matters as it follows a precedence or priority defined by Angular Ivy. This makes the resolution of multiple style bindings predictable, which is important for implementing certain complex use cases. Finally, we discussed that this change was necessary because Ivy does not guarantee the order in which directives and data bindings are applied. Ivy requires directive and component decorators on base classes that rely on Angular features such as input and output properties or child queries. We learned how this results in a pattern that makes it easy to share metadata through inheritance in a predictable way. To learn how Ivy's Aot compiler is faster and, for certain Angular projects, produces smaller bundles, we discussed how a lot of the internals were rewritten between View Engine and Ivy. We learned how the Ivy instruction set is a good fit for tree shaking to remove the parts of the frameworks that are unused by our applications. With this chapter completed, you now know how Angular strict mode preset and other configurations allow us to catch errors sooner, resulting in a more robust code base. We discussed how Angular Ivy significantly improves the testing experience as it introduces major speed improvements and useful test utilities. We saw examples of how TypeScript allows us to expect a type error in tests to create APIs that are more robust at runtime. We discussed how Aot Compilation is enabled in tests to reduce the gap between tests and runtime. This can significantly improve developer feedback when implementing tests and application code. Not only did Ivy improve our testing experience, but it is also a productivity booster when it comes to the overall developer experience. This chapter compared compiler error messages from View Engine to the same type of error messages in Ivy to demonstrate the additional context they include. We discussed how strict template type checking finalizes type checking in component templates. Finalizing meaning now we can see the types of every part of the component template. We briefly discussed how Ivy improves the update experience through messages that are output during automated migrations, and how we can use the --create--commits parameter flag to split the automated migrations into individual Git commits. We ended by discussing most of the improvements in Angular's Ide Integration, such as the new invalid template and style URL errors, tooltips displaying and declaring Angular modules, and syntax highlighting for inline component templates and styles. Chapter 3, Introducing CSS Custom Properties and New Provider Scopes, and Chapter 4, Exploring Angular Components Features, are going to prepare you for the Ivy features you're going to need to implement features on an existing Angular application. In Part 2, build a real-world application. With the Angular Ivy features you learned, we will discuss topics such as CSS custom properties, the clipboard API, component testing harnesses, and the platform provider scope, all in the context of Angular. Yeah, I think that was it. It was. And that's all I'm allowed to show you of the book, Chapter 2, because it's also available on the let's go back to the root of this GitHub repo for the book. And if we click the image here, we'll go to the product page on PackPop, and we'll see that Chapter 2 is actually available here. So you can read this whole thing yourself on packpop.com. And of course, the book is available also on all the different local Amazons and many other online bookstores, and you can buy it, as you saw here. You can buy the book as a paperback, so it has this thin paper cover. I wish it was a hardcover, but that's not the case. It looks like so on the spine, and the back looks like so. Yeah, 200 pages, 3 parts, 12 chapters, 12 feature apps, 1 real-world app, and that's what we're going to look at as the final part of this walkthrough of Chapter 2. We can look at the apps, the feature apps that are part of this, the repo here. So there's 1 feature app for inheritance, which we did discuss. This was inheritance of the metadata. So going into search here, we see that we have this base search component. So it has this private class member, an event emitter string. It has an input property placeholder with a default value of search, ... An output property search that pipes through this private search event emitter, but debounces 150 milliseconds and distinct until changed. And then we have an event handler here on search, accepts an input event, and it expects this to be an HTML input element. This value is then stored in the query constant, but if it's null, we do nothing. But if it does contain a string, we will emit it through the search private property, which is then output here after debouncing for 150 milliseconds and making sure that it's a distinct value compared to the last one emitted. So that's the base search component. You're not meant to use this on its own, as you might see here, no template. But we can extend it, and it also has a few styles here, but it's just saying apply display block to the host element because it's a custom element. All right, so we also have the search box component. It extends this base search component, and it uses the base search styles. It adds an input element to its template of type search, and it binds the placeholder property of this input element to the placeholder property, which is part of the base search component here. If you remember there, it has this placeholder input property. So we can bind to that in our template in this child component, search box component. So no implementation other than the metadata here in the component decorator, but it's inheriting these event handlers and input properties and also the output property. All right, then we have another component extending the base search component class. That's the suggested search component. So it also has this input element, but it has a list. So the ID is search suggestion. So you can go down here and find it. This data list. It doesn't render anything until you start entering something in this input field. Then it will be a native auto completion, which has these suggestions here that we have rendered using Angular. So we're looping through all the suggestions, which is an input property introduced by this class, suggested search component. But it also inherits the input and output properties and the event handler defined in the base search component. So that's it. You can spin up the app. We could do that. I have it open here. So I'll use NX console. I'll say serve. And I'll find chapter 2 inheritance. I can press run here, and it should open it up. All right. Here it is. Tuesday. I don't know what this one is. This is probably, I should check out the app component. Man, it's been a while since I did this. Here it is. App component. Okay, so it has the app search box, so that doesn't do anything. Of course, it's just rendered. Hello, nothing happening. But then we have the app suggested search. So it has a placeholder of day of event, and then the suggestions are days of week. And as we might expect, get locale day names based on the locale ID. And yeah, this is something I haven't used much, but this is an API that has also been expanded in Ivy. I'm not sure these ones are new, but yeah, interesting. You can format here and get the localized day names, and but this app might be set to English, I guess. Yeah. So yeah, the days of the week formatted using this form style.format. And translation with wide. So let's see the result of that. We have the weekdays here. So if I say T, it will suggest, this might be a bit small to you, but it's suggesting Tuesday, Thursday, Saturday, because they all have T's in them. I'll click Saturday. And I can also, no, it's not like it's only a drop down of the suggested options. I don't know, what if I have nothing? Can I get the suggestions? Yeah, I can get all of them here. And okay, Sunday as the first day of the week. Interesting. So I wonder, what if I change it to, say, French? Oh, locale ID. Oh, English is the default. I guess I would have to add a locale to use another locale. I don't want to set that up, but this is actually something also discussed in a chapter of the book. Probably chapter 1 even. All right. Guess we can also look at, rather than having the GitHub repo open, we can just look at it here. So let's check out the other chapter 2 app. That's the style bindings one. We have an app component, and this was the example with all these different style bindings, and using the host binding component with some style bindings, using the host binding directive with some style bindings, and then there are template style bindings here as well. So that was an example very similar to that stack blitz example you saw early in this video. So I can spin it up. Let's do that. Chapter 2, style bindings. There we go. Yeah. Yeah, so now it's pink, right? If I change the order, it's still pink. Order doesn't matter. The precedence matters, or the priority of the binding based on the type of the binding. So if I remember, if I remove the NG style, which is like the exclamation mark important of CSS, but for Angular style bindings, if I remove that, it will become what? Red. If I remove this property, style property binding, it will become orange. If I remove this template map binding, it will become yellow. If I remove this static template style binding, it will become what? That will depend on which has the highest precedence, component host bindings or directive host bindings. And the answer is directive host bindings. So we'll have to look here to see what color it will have. So it will be either blue or purple. But the property binding is more important than the static style binding. So my guess is blue. So let me save this one first. And blue it is. And changing the order here doesn't change the value, the evaluated style value either. So, but removing the blue, now we're left with the purple static style host binding of a directive. Removing that, and now it's some sort of gray. So let's go to the app host binding component and look at its host style bindings. So it has a component host property binding of gray. Removing that, and we're left with green, which is the static host style binding of the component. And removing that, there are no style bindings left, so no background color now. All right, let me roll back all these changes. And now it's pink again. Very good. That was it for me for today. A 2-hour session. walking through Chapter 2 of Accelerating Angular Development with Ivy, a practical guide to building faster and more testable Angular apps with the new Ivy engine by Lars Gyrup Brink Nielsen and Jakob Andresen from Denmark, with foreword by Santosh Yadav, Google Developer Expert for Angular, published by Pact Publishing. And there's like a description of what you can learn here. I shared Chapter 2 because that's already available on the Pact website, so I figured that would be okay. That was an exciting chapter. Chapter 1, what was that? I think that's let me have a look at the table of contents. But that's about new Angular and TypeScript features, important ones, major ones, in my opinion. So there's the Chapter 1 is called Discovering New APIs and Language Syntax. It has modernizing your code with powerful language features. So those are TypeScript features in recent versions. The optional chaining operator, the knowledge coalescing operator, the handling knowledge values with the new operators combined, and the native private class members that we saw. And the second section of the first chapter is optimizing regional support with improved globalization APIs. For example, bundling localizations, lazy loading locale data, dynamically setting the dir attribute based on locale direction, and art direction using directionality query. This is a really interesting example. I spent way too much in this first chapter writing this example, and it uses injects component store if you go to the repo and see the full example. That's a bidirectional, directionality aware media directive for figures. And it supports all the different locales that Angular has and loads them lazily through a picker, a locale picker, and then it changes, for example, from left to right or right to left based on the selected locale. And then you can have different images for different directionalities. So that's art direction aware. Another section in Chapter 1 is enhancing tests with stronger types and new APIs. That's resolving strongly typed dependencies with testbed and Jack, and stopping custom Angular material SVJ icons with the fake mat icon registry. So that was all the headlines of Chapter 1, and now we saw Chapter 2, the entire thing. Chapter 3 is introducing CSS custom properties and new provider scopes. So first section there is using the CSS custom properties with Angular. That's something that was accidentally enabled or added support for because of the style binding precedence changes in Ivy. So second section is discovering the any and platform provider scopes. They have subsections, one for the any provider scope, one for the platform provider scopes. These are some very interesting topics. Actually major features, capabilities of the Angular frameworks related to dependency injection, but adds new capabilities to dependency injection. They're pretty interesting and barely mentioned in the documentation, and where they are, they focus on kind of the hierarchy created of injectors, but doesn't focus on, so what can you use this for? But this is covered with some examples in this book, and you can see the examples in the repo as well on GitHub. And Chapter 4 is the final one of the first part of this book. That's exploring Angular Components features. So all the new features introduced in Ivy by the Angular Components team. So it's covering the Angular YouTube player, the Angular Google Maps components, the Clipboard API, and testing as a user with component harnesses. And so these first chapters prepares us for part 2, where we start with this real-world application called Angular Academy, which is a learning app. And then you add new features by using the new framework and language capabilities that we learned in this first part, the first 4 chapters. For example, chapter 5 is all about using CSS custom properties in a real-world app. So it's building a theme picker using CSS custom properties and controlling CSS grid templates using CSS custom properties. Chapter 6 is using Angular components. So there's like a description of some of the structure of the Angular Academy application. And then we added features to show course videos using the Angular YouTube player. And then finally, finding your school using the Angular Google Maps components. Chapter 7 is called Component Harnesses. So there's a section where we use Angular materials component harnesses. There's a section where we are creating a component harness for our own component. Chapter 8 is called Additional Provider Scopes. So this is the last one of the part 2 chapters where we're working with this Angular Academy real-world application. So the sections here are revisiting the root provider scope. So it's just a brief recap of how does the provided in root provider scope shorthand work. And then comes using the any provider scope for a configurable theme service. And then the next section is sharing information across application boundaries using the platform provider scope. Yeah. That was part 2, which is the hands-on part of the book that part 1 prepared you for by using more simpler and less extensive examples usually for all the new things. And then now working in one app throughout 4 chapters in part 2 of this book. The final part 3. Chapter 9 is debugging with the new Ivy Runtime API. So that is it's about 10 new functions replacing ngprobe. They're all mentioned, and most of them are explained a bit. And the next section is inspecting a component instance, then inspecting event listeners, DOM event listeners, and custom component event bindings. Then finally, inspecting an embedded view context. So these are all things you could do with the new Angular Ivy debugging API at runtime in development mode. So that was an entire chapter, chapter 9. And then chapter 10 is all about the Angular Compatibility compiler. So you'll learn there's the introduction to the Angular Compatibility compiler. So what is it and what's the Angular linker that's going to replace it. Next section is using the Angular Compatibility compiler. So we get all the Angular Compatibility compiler options that are relevant. And then we learn to improve the Angular Compatibility compiler for our CI and CD workflow. And finally, targeting a single application in a monorepo workspace. So there's recipes for optimizing for local development. There's recipes for optimizing for specific versions of Angular. There's recipes for improving the CI/CD workflow, optimizing for that, even for a single application in a monorepo workspace. So an entire chapter about NGCC, because some of us are going to be stuck with that for a while. Chapter 11 is called Migrating Your Angular application from View Engine to Ivy. First up is learning the Angular update process. There we look at the Angular update guide and managing Angular dependencies. Next section is performing automated Angular Ivy migrations with a subsection of making the most of the ng update command, and then reviewing the automated Angular Ivy migrations. And then final section in this 11th chapter is performing manual Angular Ivy migration. So there's managing initial navigation, optimizing change detection by configuring the ng zone, improving unit test type safety with testbed inject. That was chapter 11. And the final one is the one we mentioned a few times in this session, chapter 12, called Embracing Ahead of Time Compilation. So first section, using the ahead of time compiler for all development phases, for builds, component templates, unit test, and runtime. Next section is dealing with the ahead of time compiler's limitations, so providing values using functions, declaring metadata using functions, using tag template literals in component templates, initializing metadata variables. And then the final section of the book is initializing asynchronous dependencies. So we can provide an asynchronous dependency with a static platform provider, and resolving an asynchronous dependency with an application initializer. Yeah. That was what you'll learn about accelerating Angular development with Ivy today. I hope you enjoyed this book reading. And as a special note, I have one more thing. Here you go. Discount code for packpop.com for buying the book. There's a 25% discount active until 23rd of November, so 10 days from today when you wake up. And the discount code is NOV 2021, so November 2021. You can get a 25% discount by purchasing the books through packpop.com. You can get the digital copy, you can get the print copy with the 25% discount. So go ahead, if you like what you saw, go purchase the book. Feel free to send me feedback and questions. I'm very happy to receive feedbacks, and I'll also be happy if you leave a review on your local Amazon site. Tweet about the book, and I have a collection of all the different people sending images of the book, and I very much enjoy it. So thank you very much for that. That was Angular After Dark for today. A long one, a good one. I hope you learned something about improving your developer experience in Angular Ivy. And yeah, this is just a book to kind of level up your skills on configuration and tooling in Ivy, and new features both of TypeScript and Angular itself. Angular Material, Angular CDK, the component harnesses, the product components, strict template type checking, style binding precedence, component and metadata inheritance, CSS custom properties binding, any provider scopes, platform provider scopes, testing improvements. Yeah, those are some of the features you can read a lot about in this book. And then the final part is about Aot Compilation, Angular Compatibility compiler, the debugging API, maintaining an Angular application, migrating to Ivy, manual migrations to future-proofing your Angular Ivy application, and some recommended automated migrations and manual migrations. So just a ton of hopefully value for money in this 200-page book. So that's it for today. You have a nice time, and send me comments about the book. Bye.